Welcome in, everybody. Here we are at the beginning of week 6. We are about 2 weeks away from the midterm, by the way. So we're gonna finish talking about loops today. This whole week, and then next week we'll have another topic called methods, and then midterm is on 2 Mondays from now. So yeah, stay tuned for that. 2 weeks from now we'll have a midterm. I'll have a practice one next week sometime. All right. The goal today, we're really just going to go over a few different algorithms, in particular looping algorithms. By now, we should be somewhat familiar with the syntax for while loops and for loops. So today, we're finally going to apply some common algorithms. We're going to see a few different loops today. One loop will be kind of hinting towards this assignment that I published. There's an assignment, you can check it out on Canvas. It involves something called Loon's algorithm. So we're going to introduce a loop that can possibly help you out with this assignment. And then we'll do a class exercise, FizzBuzz. FizzBuzz, this is like an analogy for it's like an interview problem where the company will try to see if you can write a loop. So we'll do a class exercise on this, and then we'll end off with some common loop algorithms. In particular, we're going to be iterating containers. We haven't really talked about containers yet, but this is like a way of storing data. So far we've seen strings. A string is kind of like a data structure / container. It's you can think of a string as like a data structure that contains a bunch of characters. So we'll do something on that here, and then we'll end off class on reading input. So sometimes it's necessary to write loops to analyze data, and you can think of this as looping input. All right, and then on Wednesday we'll cover a few more common loop algorithms. These are going to involve nested loops. So stick around. Nested loops mean we're gonna have loops within loops. This will be Wednesday. All right. Let's start off with some hints for the assignment. So there's a published assignment out. It's called Loon's generator. I have it over here. Okay. In short, the purpose of this program is to generate random numbers. However, the number must conform to a restriction algorithm. So we'll talk about that. So there's something called Loon's algorithm here. This is a way of verifying if there are typos and identification numbers. Some companies or it's not just companies, but a lot of techniques will use a formula to check if there's a certain typo. However, this formula only works if a number was generated using this Loon's algorithm. So in practice, a lot of credit card numbers are validated this way. Your credit cards uses this Loon's algorithm. I believe your library card as well. If you have a Cabrillo library card, there's probably like a number on it. The identification number uses an algorithm that will help verify if there's typos or not. Okay, so here let's do a quick example on what it means to be a valid number. Okay, for here I'm going to pretend like we're using an 8-digit credit card number. I don't think there's really any 8-digit credit card numbers, but maybe you could think of it as like an 8-digit library card number. So I have a link to a tool here that someone created. There's an online tool that helps verify whether or not a number is valid. So here's a tool. Let's say I type in like a random number here, like 7. I'm just gonna type in like random 8 digits. So I just type in 8 random digits, and pretend that this is some sort of identification number that's supposed to pass a checksum test. Meaning, imagine this is a library card. Is there a typo in it? Let me see. Let me verify. Okay, so this is valid for some reason. I actually got lucky. I typed in random numbers. I had a 1 in 10 chance of getting this right. I mean, of getting a valid one. That's crazy. See, check it out. If I change a single number, what's gonna happen? Like, if I change this last number to a 6, is this a valid number now? Let me check. Verify. No, it's not a valid number for some reason. All right, let me change another number. I'm just gonna change this to a 5 over here. Is this valid? Nope, it's not. All right, let me change the last digit. Okay, let me change this. Is this valid? Nope. Is this valid? 1? Nope. Let me keep changing numbers till it is valid. Okay, cool. So I changed the last number to 2 now, and this is valid for some reason. Okay. So yeah, imagine this as a credit card number. I know there's not really 8-digit credit card numbers. Yeah, you could type in 16 digits here if you want. Like here, let me type in 16 digits. 1, 2, hold up. 1, 2, 3, 4. 1, 2, 3, 4. Okay, I just typed in 16 digits. Did I? No. 1, 2, 3, 4. Okay, there it is. I just typed in random 16 digits, and imagine this is a made-up credit card. Is it valid? No, it's not valid. But what if I change this last number? Let me see. 0. Nope. 1. Okay, this is valid for some reason. Okay, so why is it valid? Some identification numbers must conform to a formula. So let's go ahead and go through this formula together so we can see how things are valid or not. All right, so here we're gonna do this on paper. Typically I do this on a whiteboard, but folks can follow along on paper if you want. I'm gonna do it on the slides over here. I mean, not slides. This it's like a paint. Okay, so first make sure you understand the algorithm before coding anything. This way you can fully understand the solution. You don't really want to be implementing any code unless you understand what the overall goal is. So let's do an example on paper. For here, I'm going to use this example number that I have in the assignment. I gave an example number right here, so let me copy this. So these 8 digits are valid for some reason. All right, let's figure out why. So let's do it on paper. All right, so let me go on paper here. Let me get that number out. So we have an 8-digit number. Let me type it in real quick. Okay, 7 3 7 7 5 5 3 8. Okay. Okay. Cool. So this number is valid for some reason. I do have the pseudocode for the algorithm over here. A pseudocode is like an explanation of how the algorithm works. It's like it's not real code, but it's like an English version over here. So one possible way we can figure out if a number is valid is by calculating the sum from right to left. So imagine you take the rightmost digit and then go to the left from there. So we're gonna accumulate a modified sum. Okay, we'll talk about what modified means. But basically, in short, you can verify by adding up all of these numbers, right? Adding up all of these numbers in some way, and then checking if it's divisible by 10. If it's divisible by 10, then it's a valid number. All right. So let's go through what it means to accumulate a modified sum from right to left. Okay. So you can imagine this as an integer, and maybe we want to keep track of a modified sum. So let me pretend to declare a variable here. Okay, imagine we declared a variable that kind of maintains the sum. So this is a variable, I'll call it sum. Okay, and I'll initialize it to a 0. Okay, cool. So how the algorithm works is by accumulating the sum from right to left. But every other digit is treated a little differently. So let me put like a star here on every other digit. I'll just use a triangle. So every other digit starting from the right would be special. Like this 3 right here is special, and then this 5 right here is also special, and then this one is, and then this one is as well. All right, we'll talk about what it means to be special, but basically we want to accumulate the sum. So this one is normal. This least significant digit is normal, so we can just accumulate the sum normally. So we're just gonna treat this 8 normally, like we're just gonna treat it like an 8. Let me put another text box here. Okay, cool. So cool. We'll treat this normally. Okay, so that now the sum becomes 8 because we're accumulating it. But now imagine we're iterating to the next number. So now let's say we go to 3. 3 is a special number. Every other number in this algorithm is supposed to be doubled. And if doubling the digit results in a value greater than 9, then we would subtract 9 away from it. All right, so let's double this number. So double, if we double 3, this becomes 6. Let me just copy this over. 6, okay? So we doubled it. Is 6 greater than 9? No, it's not. So we don't do anything to it. We just have to accumulate the sum. All right, so 6 gets accumulated. Sum becomes 14 now. All right, sum becomes 14. Okay, and now we're going to iterate to the next digit. So 5, this is going to be a normal number. Okay, 5 is treated normally. So this is not doubled at all. It's just going to remain as 5. All right, so normal number, we're going to accumulate it to the sum. So the sum becomes 19. Okay, and now let's look at 5. This is a special number, meaning that we're going to double it. So doubling it results in 10 here. Okay, but it's special. If doubling it results in greater than 9, we'll subtract 9 from it. So what do we do at 10 here? All right, this is greater than 9, so we got to subtract 9 from it. So let me go ahead and modify that. Let me put a x over here. Okay. Okay, cool. So 10 is greater than 9, so we're going to subtract 9 from it, meaning that the modified digit ends up being 1. Okay. All right, people see what's happening here. So what happened here is this right here. We subtracted 9 from it. Okay, so now that we have the modified digit, we can accumulate the sum. Okay, so sum becomes 20. All right, let's go ahead and iterate to the next digits. So 7, this is a normal number, so we don't need to double it or anything. We're just gonna treat it like a normal number. So this is 7, and we're gonna accumulate the sum, becomes 27. All right, and now 7 right here, this is a special number, so we're gonna have to double it. Okay, so double it. This will become 14. All right, what happens to 14 here? Right, what happens? Well, it became greater than 9, so according to Loon's algorithm, we got to subtract 9 from it. Okay, meaning that this becomes a 5. 14 minus 9 gives us 5. So our modified digit is 5. All right, modified digit is 5. This means our sum becomes 32. All right, let's go and move on to the next one. So 3, this is a normal number. We don't double it. This becomes 6. I mean, no, not 6. It remains as 3 because we don't double it. So the sum here becomes 36. I mean, 35 here. 35. Okay. And then 7 right here this is a special number, so we're going to end up doubling it. Okay, so let's double it. This becomes a 14, and we see that 14 is greater than 9, so we subtract 9 from it. So it's going to end up being 5 here, because 14 minus 9 is 5. Let me put an X here. Okay. All right, so yeah, we get the 5, we'll accumulate it, so sum becomes 40 here. All right, people see what happened here? So all we did was perform this algorithm to verify if a number is valid or not. We went from right to left, and then we calculated the sum. But the sum of each digit, it's every other digit is doubled, and we'll do the modified. Subtract 9 from it if it's greater. Now we're at the last step. We finished calculating the modified sum, so we can check if it's valid. If it's divisible by 10, it's valid. All right, this is divisible by 10, so it is valid. All right, people cool with this so far? So yeah, you kind of see how this identification algorithm is working. In practice, when you're typing in like a credit card number to a website, one of the first verification algorithms is this Loon's algorithm. Before sending the card up to the bank, the program would check to see if there's any small typos, and this would help us check. All right. Okay, any questions about this so far, folks? Okay, cool. So if you understand that validity algorithm, the assignment should be a little easier, because the whole goal of the program is see if you can write a program that generates a random 8-digit number, but the 8-digit number must conform to the algorithm. So these are all examples. I ran my own program like 3 different times, and it gave me 3 different valid numbers. So you could check these over here. Let me pull it side by side. Okay, so let me just check these. So this one, is this valid? Let's see. Verify. Yeah, this one is valid, and if I run the program again, it gives me this number. Your program is probably going to be different because the randomness. And okay, this one is valid, and then this one is valid too. So, oh yeah, it's pretty much the whole goal of the assignment. If you understand this algorithm here, it's going to be a lot easier. This diagram that I have. Did I exit it on accident? Oh, it's right here. Yeah, if you understand this, it should be fine. So here, let's talk about one possible approach you can do to this. Right, there are tons of approaches we can do. Some of them are inefficient, some of them are efficient. I recommended a more efficient algorithm. One way you can think of this is by first generate a random 7-digit number, and then find out what number you need to put at the very end. So what I'm pretty much saying is you can generate like a random 7-digit number. So let me put let's pretend I generated a 7-digit number. So let me put like 1, 2, 3, 4, 5, 6, 7. Actually, let me put in some random numbers. 1, 2, 3. Okay, here's 7 random numbers. Let me see if this is valid. So I'll verify. Okay, this is not a valid number. It's not a valid 7-digit number. But we can add a number that will make it valid. So I could put like 0 here. I could put 0. Is this valid? No, it's not. How about with a 1? Okay, let me try 1. Nope. And what about 2? Okay, 3, 4. Okay, 5. Okay, 6, 7, 8, and then 9. Okay. So for some reason with 9, this is a valid number. But do folks see how this is an inefficient solution? It's inefficient because I brute forced this 9. I kind of just guessed and checked. You know what I mean? Like I tried out every number. I tried out every digit from 0 to 9 until one of them were made it valid. So this is inefficient because it can take a lot of work. One way you can think of a more efficient algorithm is by doing a bit of math to figure out what the last digit should be. And the math would just require you to calculate the modified sum of the 7-digit number, and then finding out what number satisfies that sum. Okay, so let's go through an example real quick. Let me use this number over here. So pretend we generated a random 7-digit number. So let me just use this number over here. Okay, so where's my... Okay, let me erase all of this over here. Yeah, I'm just gonna erase all of this. Okay, so let's say we generated a random 7-digit number. Okay, here it is. Okay, the goal of the assignment is to create 8 digits, so this is incomplete. But you can think of the last digit as like a check digit right here. So imagine this is, let me highlight this as red. So imagine that this is a check digit. The whole goal of this number is to satisfy the whole equation. All right, so one way you could think about this is by calculating the modified sum of these 7 digits and then doing a bit of math to get this. All right, so the modified sum, if you might remember, every other number is treated specially. So let me go ahead and label it. Every other number from the least significant digit. So it's going to be this 2 right here, this one over here, and then this one over here. These ones are treated specially. All right. So yeah, one way you could think about it is first generate a random 7-digit number. So we just did that. Well, I hard coded it, but you can do this later. And then now we can just calculate the modified sum. So let's do that. Let's go ahead and declare like a sum variable. Let me insert a sum. Here's my sum variable. Okay, here's my sum. I'm gonna initialize it to 0. Okay. So let's pretend that we're going to iterate through all of these and get the modified sum. All right, so let's get the 2. 2 is a special number because it's every other. So we can go ahead and we do need to double it. So doubling 2 gives us 4. Okay, doubling 2 gives us 4, and what happens here? Nothing, because it's not greater than 9. Right? If it were greater than 9, we would subtract 9 from it. So this remains 4. The sum is 4 here, so we accumulate it. All right, and then 8, this is treated normally. So this is just 8. All right, this is just 8. So we accumulate the sum, becomes 12. All right, and then 1 here, this is a special number, so we're going to double it, and it becomes 2. Okay, but then there is a condition. All right, we got to check if it's greater than 9. It's not, so it remains 2. So the sum here accumulates to 14, and then now we can accumulate 3. This is the normal number. So 3 here, makes the sum become 17. Okay, and then 4, this is a special number, so we're gonna double it. Double it gives us 8. 8, okay. And is 8 greater than 9? No, it's not. So sum becomes 25 here. All right, almost done. Okay, so 9. This nothing. This is a normal number, so this remains at 9. Okay, this remains 9. So sum here becomes 34, and then finally, the 8. All right, this 8 is doubled, so this becomes 16. But what happens to the 16? Right, it's greater than 9, so we end up subtracting 9 from it, according to the Loon's algorithm. So that means this becomes 7, because 16 minus 9 is 7. Okay, let me put a... Okay, so the modified digit becomes 7 here. And finally, our sum increases. So our sum accumulates 7. This becomes 41. All right, people cool with this so far? So we're applying this pseudocode right here. First, we generate a random 7-digit number, okay, and then we calculated the modified sum. This is 41, and then we need to find out what the check digit is. Okay, the check digit is this last number. It's a number that makes the sum divisible by 5. I mean 10. So yeah, what should the check digit be? You can use the sum to figure this out. So based off the sum, we can see that the check digit must be 9, because 9 brings us up to 50. So let me put a... Can I put a line here? Okay, let me just put an arrow here. Make this thicker. Okay. Cool, so now that we got the sum, all we have to do is a bit of math. Like do a bit of math and say, hey, what number brings us up to the next multiple of 10? So here it's 9. So this is this becomes a 9 right here. All right. And then yeah, once you get the check digit, you can just put it at the end of the number, and that'll give you the valid number. So does that kind of make sense? How here this is by adding 9, this becomes valid, right? None of the other numbers would work because it doesn't satisfy the check digit, right? Okay. So yeah, I hope that kind of makes sense. Any questions about this so far? Okay, cool. Yeah, so as long as you can do it on paper and understand these steps, then I would start coding from there. Because next, you'll just need to know how to generate some random numbers and implement loops. So I have an algorithm down here which might help you visualize certain pieces of this assignment. The part of the algorithm is to calculate a modified sum. Like how do you take a number and go through it to sum up the numbers? Well, one way you could do it is with this algorithm here. There's this while loop. This while loop is pretty much taking an integer and it's iterating from right to left, and then ends up kind of adding them all up and printing out the sum in the end. So here, let's talk about this algorithm. So let me. It's probably a good idea to test this out over here. So let me make an example. I'll call it digit. Digit sum. I'll call it digit sum.java. Okay. The goal of this file is to help us visualize how to make a loop to sum up digits. So I have an algorithm here. I'm just going to write it from scratch here. So imagine if we have like a hard-coded number. It's equal to like, here, you know, I'm going to use this actual number over here. The one that I just went over. Where is it? I'm going to use these numbers over here. Okay. So imagine if I hard-coded this number. Let me remove these white spaces. This is hard-coded. In practice, you would kind of want to, generate this using the random library, random class. So yeah, imagine if we wanted to write a loop to go through this integer and calculate the sum, meaning like what's 2 plus 8 plus 1, right? So we could initialize like a variable to 0 and write a loop that will accumulate this number. Okay, this loop is a little tricky to understand because there's some weird math that goes on behind it. But basically, there's this condition that tells us when the number has run out of digits. Because one way you could represent this, like how to calculate the sum, one way you could represent it is by going through each digit, but chopping them off as you go. You know what I mean? So like take 2, accumulate it, but chop it off, and do the same with 8, chop it off, and chop it off, all the way until it becomes 0. Right, so at some point it's going to become 0 and we run out of numbers, and that should terminate the loop. Right, this is just one way you can think of it. So there is a modulus operator. It's you could do like this mod 10. People remember what mod 10 does? That this is saying, what is the remainder if we divide by 10? All right, so yeah, a pop quiz. Let me pull up the J shell over here. A quick pop quiz. You'll probably see this on the exam or something. Like, what is 54 mod 10? All right, what's the remainder of dividing by 10? It gives us 4 because it's 10 goes into 54 5 times, and we get remainder of 4. All right, but take that a step up. Like, what's this number over here? What happens if I mod this by 10? All right, this gives us an 8. Hopefully that makes sense because there's a remainder 8 here when we divide by 10. And then let me do another number. Okay, what's this mod 10? All right, this gives us 7. So you can think of this mod 10 as just grabbing the last digit. All right, it's grabbing the last digit, or it's actually making a copy of the last digit. It's making a copy because we declared a variable called integer digit, and then we're going to store the result. So we're making a copy of the last digit. All right, so you could do that and then just accumulate it. You could go ahead and accumulate it. Well, actually, before accumulating, let me print it out. So let me print out what the digit is, so you see what's happening. So this is like a debugging statement. In programming, in an intro class, you'll find yourself printing a lot just to kind of visualize what things are. So let me look at some digit and then put the digit here. Okay, but there's one important step here because this is still going to be an infinite loop. Check it out. If I run this digit sum, oh, I need a CD. I need to change directory into examples. Okay, let's see what's going to happen here. Okay, so I ran it, but I get an infinite loop. You see how the program is like spamming my terminal right now? This is an infinite loop because our number is always greater than 0. You know what I mean? Like here, all we're doing is getting we're making a copy of the last digit and just printing it out. But the number never changes. The number never changes, so yeah, we're in an infinite loop right now. So let me quit this, Control C. Okay. One way we could think about the problem is by chopping off each digit as we go. So when we're done with the digit, we could chop it off. And one way you could chop it off is by using integer division. You could say num is equal to num divided by 10. So this is integer division, by the way. Integer division, which pretty much chops off the last digit. Okay, so here let's see what this does real quick. I'm gonna just go on a J shell so I can test folks real quick. All right, let's talk about what integer division is. It's been a while. It's been like a few weeks since we've seen integer division. But let's say I have like an integer, like 12. Okay, and then I divide by 5 right here. If we treat them both as integers, what does this give us? It gives us 2. All right, so people see why? Because with integer division, we do something called truncating. Truncate means to ignore the decimals. So this should have been like 2 point something, but since we're dealing with integer literals, it chops off the decimals. It doesn't round. Okay, so same with this right here. If I take like this number right here, and let's make it smaller. Let's go like 17 divided by 10, or not mod. Divide by 10. What does this give us? This gives us a 1. It should have been 1.7, but these are literals. Right? I mean, you could put like 17.0, which tells Java to treat them as doubles, and then give us a 1.7. But with integer division, it allows us to chop off the last digit. You know what I mean? Like if I did this number divided by 10, how many times does 10 go into here? It goes into it 1723 times. There is a remainder, but since we're doing integer division, we don't care about it. We don't care about the decimals. All right, so that's kind of what this line is doing. It's chopping off the last digit. So you could verify this by looking at the output. So let me do an output here. Num is now. Okay, let's go ahead and visualize this. So I'm just doing some print statements so we could visualize what's happening. And okay, here, let me put in some equal signs here so it looks easier to read. Let me do a vertical, horizontal bar here. Okay, let's go ahead and run this. Okay, so here's the print statements that should kind of help us visualize what's going on. Hold on, let me run it again. Okay, so in the beginning of the program, you see how it says looking at digit 2. This is because in the beginning, the num has 2 in the end. So when we make a copy of the last digit by modding, we get 2. And then you see how this integer division, this is dividing by 10, but it's chopping it off. It's chopping off the last digit because that's the behavior of integer division, especially when we divide by 10. So the 2 gets chopped off. The 2 gets chopped off, so now we see number becomes the number we have without 2. All right, so this loops over and over again. We grab the last digit, chop it off, do it again, chop it off, right, and do all the way until all the numbers are chopped off, and at some point number becomes 0. So when the number becomes 0, the loop becomes false, and we end up terminating. All right, so yeah, this is one way you could visualize how to calculate the sum. Now all we need to do is accumulate the sum. All right, so sum is 0. All we need to do is make it bigger in the loop. So where should we make sum bigger? Okay, well, we could actually do it anywhere in the while loop, as long as it's after getting the digit. As long as we do it after making a copy. In my opinion, it would probably make sense over here. in the middle. So we could say sum is now equal to sum plus the digit. So this is accumulating. Okay, accumulate the digit. And you know, I could print it out as well. Let me print it out. Sum is currently okay. Let me go ahead and test it now. Cool. So Java, boom. And okay, let's look at it. So we started off with this number here. Let me look at it. Okay. Okay, cool. So looking at digit 2, so that's the first iteration. Sum becomes 2 because we accumulated that. And then num gets chopped off. We do integer division to chop it off. And then we'll check the condition. Is the num greater than 0? Yeah, it is. It's still greater than 0. So we'll do another iteration. All right, so yeah, folks can go through this, kind of trace it. But make sure you understand how this is being hand traced. I have a little diagram here, this table that will help you visualize it. Sometimes it's necessary to trace your code by hand. Like an analogy. Here I'm kind of tracing it by hand by using like a bunch of print statements. But you know, if you work better on paper, you could draw a table and fill in the blanks. Basically, this table is keeping track of the variable. In the beginning, we initialized 2 variables, and then inside of the loop, we have a digit here, which changes every iteration. So yeah, this table here is pretty much tracing through each iteration. All right, so if you understand this loop here, the assignment should be a little easier because that's a little piece of it. That piece will help you calculate the modified sum. All right, there's just a couple things you have to think about, like how do you treat each number a little differently? Because right here I'm not really getting the right sum. Like see, check it out. You see how I added all of these together, and then the sum becomes 35. Here, let me run this again. My terminal keeps breaking. It keeps like putting new copy of something. But you see how at the very last iteration sum is 35. Let me make sure it is 35 over here. Let me go at the bottom here. Sum is finally. Okay, let me just run this again. Oh, I got an error message here. Let's see what happened here. No suitable method for print line. Oh, I used the wrong method here. But basically, the print line method only takes 1 argument. I meant to use printf, the print format, which can take multiple arguments, multiple things in the parentheses. Okay, so let me run this. Okay, cool. So sum is finally 35. Note that this is an incorrect sum, by the way. It is the sum of all of these numbers put together. Like if you add up 2 plus 8 plus 1, let me think real quick. 2 plus 8, 10, 11, 14, 18, 27, 35. Yeah, so if you add up all of these numbers, they become 35. But you remember how here, like the sum of these numbers don't equal 35? It's 41 here. The reason is because every other number was treated specially. And since we're not treating every other number specially, we end up getting a incorrect sum. So that's kind of the tricky part in this assignment. You should probably spend some time thinking about how to modify this while loop. How do you modify this while loop so every other digit is treated a little differently? All right, so that's going to take a bit of time to think about. one way you can think about it is by maybe making a Boolean variable. Once again, Booleans are either true or false, and you could make that, you could flip-flop that variable. You could make a variable true in the beginning and then flip it to false, and then go to next one and flip it to true, and go next one, flip it to false. So yeah, you could make a Boolean variable if you're familiar with these Java. So you could look at Java Booleans. This is stuff we did a few weeks ago. But yeah, you could create a Boolean and kind of flip-flop it back and forth. That's probably one easy way to think of it. Or another way you could think of it is by maintaining a counter. Like you could create a variable that keeps track of how many digits you went through. And then if you're on the even amount of digits, then you could treat it a little differently. So I'll let folks think about it. A Boolean is probably the easier way to think about it. Just create a Boolean variable and then flip-flop it, meaning that every time an iteration happens, just flip it. All right, and this will help you make decisions for the branches. All right. Okay, any questions about this? We spent about 45 minutes pretty much giving hints on this assignment. I don't want to give away too much of it just because there's like so many different solutions. So I'm going to give a lot of room for creativity. Okay, any questions about this, folks? Okay. Looks like people are doing okay. Nice, nice. Okay. Cool. Let's carry on with class then. So let's go do some more practice. The goal of today is really to expose us to more real-life applications of looping algorithms. All right. Last week we covered the while loop and for loop. Make sure you're comfortable with this before we move on. But let's go ahead and start off with a exercise. So let's do this thing called FizzBuzz. You can imagine this is like an analogy for early interviews. If you ever plan on working at like a software engineering company or something that requires some sort of programming experience, it's likely that one of the interview questions will ask you if you can write a loop. So this is pretty much one of those questions. It's saying, hey, can you write a loop that does something? In particular, this one is asking us to write a loop that goes through a certain amount of numbers. And for all those numbers, print fizz if it's divisible by 3, buzz if it's divisible by 5, and then both of them if they're divisible by both. So here, let me put this on a notepad here so you see what I'm trying to, you see what the expected output is. Okay. So the expected output of this class exercise, yeah, there's gonna be a class exercise. So we'll give it like 10-15 minutes. But basically, like let's say we were given an integer n. Okay, so the n doesn't matter. But let's say I hard-coded n to be like 21 or something. Okay, so this is hard-coded. N doesn't matter, but basically it's saying for every integer up to n, do some different print statements for each of them. So every number underneath n, this means 0. So like let's say we're at 0. Is actually I'll start from 1. I'll start from 1 just so we don't have to talk about like whether or not 0 is divisible by something. I'll bring that up last. But we could start at 1. So is 1 divisible by 3, or is it divisible by 5? No, it's not. So since it's not, we just leave 1 normal and just print it like that. And then what about 2? Okay, is 2 divisible by anything? No, it's not. So that remains the same. Okay, and then is 3 divisible by anything? Yeah, 3 is divisible by 3. So the expected output should be fizz. All right. So yeah, I'm pretty much writing the expected output here so folks can try it out. And then let's move on to the next number. So 4. Is 4 divisible by 3 or 5? No, so nothing happens. Okay, and then 5. 5 is divisible by 5, so we'll print out buzz. Okay, and then 6. What happens with 6? All right, 6 is divisible by 3, so we can print fizz here. All right, and 7. This is a prime number. It's not divisible by any of them. 8, nothing. 9, fizz. Okay, this is divisible by 3. 10 is buzz. Okay, it's divisible by 5. 11, nothing. 12, divisible by 3. Okay, 13, nothing. 14, 15. What happens with 15? 15 is divisible by both 3 and 5. So we're expected to just print fizz buzz. All right, and then 16, not divisible by either of them. And then 17, nothing. 18 is divisible by 3. 19, 20 is divisible by 5. So just buzz. And then 21. 21 is divisible by 3, so this is fizz. All right, so that's the goal of this possible interview question. It's saying, can you write a loop that goes up to some number, but all of those previous numbers should print out something. All right, and 0 here, for the sake of simplicity, we can assume that 0 is divisible by both 3 and 5. So if you do include 0 in, this should print fizz buzz. All right, so yeah, people seeing the goal here. N could be anything. You can just hard code in your program. All right, so yeah, let's give it some like 15 minutes. Let's give it like 10-15 minutes, and yeah, can folks write a program? That's I hope folks get started with it. So let me make a folder here. File, I mean. I'll call it fizz buzz. Okay. So here's fizz buzz right here, and temporarily I'm just gonna hard code the upper bound is equal to 21. So this is hard coded, but the whole goal is n could be anything. So your loop here should reflect whatever the n should be, right? Like if n was 25, then your loop should go all the way to 25 using this variable here. All right, so let me just use 21, and then to do, this is the class exercise. Okay, let's go ahead and fizz buzz it. Let's give this 10-15 minutes. And yeah, make sure, I'll highly recommend folks try it out themselves, especially if you're like a computer science major, or maybe you're wanting to apply to some software engineering job soon. I recommend trying it out yourself and troubleshooting through the process. So please don't, there's nothing stopping you from, looking up the solution and just copying it down. But you're not going to get a lot out of the class if you did that. Yeah, so just, it's okay if you get stuck on it. That's what I'm saying. As long as you're kind of thinking about it and going through the problem solving process. Like, oh, why is my problem off? Why am I getting logical errors here? This is an interview problem, and in a lot of the technical interviews, they're measuring to see how you think. They're not really measuring to see if you can jump to the solution right away. They kind of want to see if you can think your way towards the solution. All right, so yeah, let's give it like a 10-15 minutes. I'll give it a 15-minute timer. There's lots of room for logical errors in this class exercise. Okay, let me pause the recording right here. And yeah, folks on the Zoom, if you're having trouble with this, feel free to let me know. I'd be happy to take a look at your code. Okay, 15 minutes. All right. Hopefully people gave that a shot. Okay, I'm gonna go over a couple of possible solutions. So you could have done this in a while loop or a for loop. Either of them work. They're really the same thing. But it's probably going to be easier to represent in a for loop and more appropriate too. For loops are good for if you know the range. Like if you know how many iterations you're going to do, the for loop is good for this. In this case, we do know our range. With FizzBuzz, we know our range from going all the way from 0 all the way to n. We know both the lower bound and the upper bound, so we could represent in a for loop. You could do in a while loop too. This is you're gonna end up having longer code, but in my opinion, while loops are better suited for things that are possibly infinite, or when you're not sure what the range is. All right, so let me do this in the for loop. Okay, cool. So we know our upper bound. It's right here, the n. So a for loop is good when we know both the upper bound and lower bound. So here in this case, we know the lower bound. It's from 0, because we're for every positive integer less than n. So we could initialize a for loop starting at 0, and we do know the upper bound as well. We could the condition we could say all the way up to n. N could be anything. In this case, it's just 21. And then finally, the incrementer. Now, once again, the prerequisite for today is make sure you understand how the while loop works. So yeah, right off the bat, this for loop says start at 0 and end when we get to the upper bound. Right, and then we're increasing by 1 every time. Okay, so it's probably a good idea to test it step by step. So for now, I'm actually going to print out what I is. If we want the output to look exactly like this right here, then we should probably print the number and then colon. So let me print out let me print out the number and colon. Print line. Wait, no, I'm not gonna. Oh, I'm not gonna use a print line. Let me use a. Okay, this is gonna look weird, but I'm gonna do a print with no line. I'm just gonna print out I, and then a space. Or actually, let me do a print F here. Let me make a print format. This way I can put like some number here and then colon space. Okay. So put the I here. This way we can, our goal is so we can get these numbers here. 0 colon, 1 colon, 2 colon. So that's hopefully what's gonna happen here. And this is gonna look weird because I'm gonna print out a new line at the very end of it. I'll explain why. So this is empty, but it's actually printing a new line. So it goes to the next one. If I were to run this, check it out. So Java FizzBuzz. You see what's happening here? It's all we're doing is printing out the numbers and then colon space. Now the reason why I put the new line here, it's a little tricky to see why, but if it weren't for the new line, I'm gonna end up with everything on a single one, and it would be a little harder to read. But yeah, I did a new line here. You might be wondering why I did it separately. Like why didn't I put the new line here? Like right here. See, I put a new line here, so it's gonna give me the same thing. You might be wondering why I didn't do this. It's because we're planning on having text on the same line as a number. So if you want text on the same line as a number, it's already too late at this point because we did a new line. Meaning if we were to print fizz or buzz, then it's gonna end up being on the next line. Like it's gonna end up looking like this right here. It's gonna say fizz buzz on the next line, and then for 3 it's gonna say fizz on the next line. So the reason why I'm gonna separate the new lines is so we can have the numbers in between. So I hope that kind of makes sense. So yeah, one way you can handle it is by printing all of these. Here, let me use a different terminal. I'm still using the same PowerShell, but I'm just gonna put it side by side instead. It might be easier to read. 12J. Oh, these are my downloads. CS-12J. Okay, cool. So let's go in Java. FizzBuzz. And okay, cool. Just making sure it prints. Okay, cool. I separated them because we want the FizzBuzz to be before the new line. So let's go ahead and implement these. Let's go ahead and handle these branches. You can think of these as like 2 or 3 branches. So we could say, hey, if I is divisible by 3, then print fizz. So yeah, hopefully people got a little far. So we could say if something, then we could print fizz. So I'll print fizz here. Okay, print. I'll just do print with no format because I'm not planning on putting any string formatters in here. So yeah, what's the condition to print fizz? Because the condition to print fizz is if it's divisible by 3. And it's divisible by 3 if you divide it and there's no remainder. Okay. So you might remember this from the J shell over here. Okay, here's my J shell. Let me just pull it up. What's 6 mod 3? This is 0. So there's no remainder. What's 7 mod 3? This is 1. There's remainder 1. And then 8 mod 3, this is remainder 2. So yeah, you could check if a number is divisible by 3 by checking if the remainder is 0. Right? So you could just say if I is divisible by 3. All right, don't forget it's double equals. We use double equals for comparing equality. All right, print fizz. All right, let's go ahead and test this real quick. This is just a single branch inside of a loop. So let me test this. Java, FizzBuzz. Okay, people see what's happening here. So we got, it prints out fizz for every number divisible by 3. Okay, this looks good. Now all we need to do is for the buzz. Okay. We just need to get the second branch. So here's the part where there might be some logical errors, and there's lots of room for creativity. All right. Some people might have done an else if here. Right. What do you think is going to happen if I put an else if for the buzz branch? All right. So this is buzz is happening when it's divisible by 5. So what do you think is going to be the behavior? If I said, okay, else if is divisible by 5, print buzz. All right, what do you think is going to happen? Let's see. It looks right. If I run it, I see I ran it, it kind of looks right. You see what I mean? Like it's printing fizz for all of the multiples of 3, and then it's printing buzz for all the multiples of 5. All right, it's kind of working, but what's wrong with this? There's a logical error here. The logical error is we never printed FizzBuzz if I is divisible by 3 and 5. And in this case, there is one number that satisfies it. Where is it at? Where's my terminal at? Here it is. It's a 15 over here. 15 should have printed FizzBuzz because it's both divisible by 3 and 5. But why didn't it? Well, we have an else if here. The control flow for an else if goes like this. If the earlier one is true, the next one won't be checked at all. Right? This was a very big takeaway from 2 weeks ago. Right? Here we have 2 connected branches. They're like a fork on the same level. So in this case, 15, the first one became true. So the control flow says ignore the next ones. Right, does that kind of make sense? So one way you could fix this is by disconnecting them. You could disconnect them by saying if for both branches. So now these are like two separate forks in the road. If I run it now, you see how 15 prints out both fizz buzz. Right? The reason why is because we separated them. They're both if statements. So if an earlier one is true, the next ones will still be checked. All right, people cool with this so far? Okay, yeah, so there's tons of ways you can represent solutions to this. If you did go with the if and else if, let me rewind this. So if you did get the else and else if, I need to save this. Save. This gave us a logical error. One way you could fix it that people might have done is check if it's both divisible by 5 and 3. So you could do something like saying system.out. Whoops, not here. You could say print fizzbuzz here if both sides are true. Both sides meaning like if it's divisible by 5, divisible by 3, I mean. So you could say if it's divisible by 3 and I is also divisible by 5, then print fizzbuzz. Right? So you could also do it this way, but what do you think is going to happen? All right, let me play it. All right, feel free to pause the video and because these are possible exam questions. Exam questions like, what is the behavior of this loop? The behavior of this loop is still the same. It never printed fizzbuzz for 15, but it should have. So yeah, hopefully people see the reasoning behind this. It's because the ordering. Well, we checked to see if this is true. This is true. So next ones won't be checked at all because that's how the control flow works for connected branches. So one way you could fix this is by checking the more restrictive condition first. This is the more restrictive condition. So if we checked this one first, let me put it. Let me copy this over. So I'm just going to put it at the top over here as an if statement and change this to an else over here. So yeah, you could make the top an if, which is the most restrictive one, and if the restrictive one isn't true, then we'll check at the smaller ones here, and this should work. So let me run it, and there we go. We get fizzbuzz for 0. That's divisible by 5 and 3, and then fizzbuzz for 15. Okay. People cool with this so far? So yeah, this is fizzbuzz. The whole point of it is to help folks think about certain loops. It would be a good lab activity to convert this to a while loop. This is a for loop. If you want to spend some time converting to while loop, this would be a good practice. This way you get comfortable with both syntaxes. All right, let me test it with a different upper bound actually, just to make sure. Let me go all the way up to like 100. Let me change the upper bound to 100 and let me run the program again, just to make sure it's working. Okay, cool. So it went all the way up to 100, and yeah, this looks good. Fizzbuzz for 90. Yeah, because 90 is divisible by 3. Wait, is 90 divisible by 3? Oh wait, I think I have a logical error here. Why did I print fizzbuzz? 90 is not divisible by 3, right? Huh. Is it? Let me pull up a J shell here. 90 is divisible by 3, really? Let's see, 90 mod 3. Give it a 0. Oh, it does. My bad. I'm totally fried. I'm totally fried. 90 is divisible by 3 because it goes into 30 times. My bad. I was totally fried. I was thinking this said 100 for some reason. My bad. Okay, 90 is divisible by 3 and 5. Let me check. 75 divisible by 3. Yeah, it is divisible by 3 because it goes in 25 times. And then 60 divisible by 3. Yeah, this looks good. And okay, cool. Yeah, I'm just sanity checking this output. And yeah, it looks good for me. So that is fizzbuzz. I know people might get messed up on these lines, like what did a print line. Feel free to mess around with these to see what might happen. I think you don't have to print out a line separately like this, but yeah, you could try out different ways. Okay, because if I get rid of this print line here, then everything is going to be on one line. And yeah, there's ways of fixing this, but in my opinion, this is a little cleaner. Just saving it for the last. Okay, that's FizzBuzz. Any questions about this? Okay. Cool. All right. Hey, let's move on then. Cool. For loops. Okay. Yeah, let's do a couple more examples. Hopefully people aren't getting too tired yet. Let's do two more. So let's do one loop that will help us visualize what it means to iterate a container. Right, and then we'll end off class with reading input. Right, so just two more things. Let's do a way of iterating through a container. So we haven't really talked much about data structures in Java, but sometimes we need to organize more data. So far, we've really only seen like an integer. We've seen booleans. We've seen doubles and strings. A string is kind of a fancy variable, by the way. It's not like a primitive. Like let me pull up my JShow over here. So in Java, we have like integers. We got integers, we got doubles, we got floats, we got boolean. These are all like primitive data types. But with strings, the capital string, it's like a special type of data. It's called a class. And basically this is like a container of characters. So we haven't really talked about characters yet, but there is a key, a type called char. This is short for character. And but basically with a string, like let's say I declare a string to like hello. So let me just declare a string hello. Enter. You can imagine text is like a fancy object. In particular, this is like a collection of characters, meaning that we can access individual things if you wanted to. Like if for some reason you wanted to access this first character, you could use this method called I think it's called char at, and then give it some position. So this would give us h in single quotes. Single quotes in Java will represent characters. And if for some reason you want to get the element at the 1th position, this gives us E, and then 2 gives us L, 3, 4 gives us O, and then if we went to 5, this gives us a runtime exception. A runtime exception because we went out of bounds. Okay, so we could think of this as a container of things. In the future, we'll talk about arrays and data structures, which are ways on organizing data. And sometimes it's necessary to write loops that goes through it. So for this quick example, let's do a small loop that for some reason you wanted to calculate how many vowels there are. All right, and just to motivate this a bit, like why are we counting vowels? You know, it might seem like an annoying exercise, but this is useful in like maybe bioinformatics. If anyone has worked in like DNA, like let me pull up the DNA here. Have you ever heard of DNA before? The DNA is, you might remember from biology class. You can visualize DNA as a string. where each character represents a molecule. So in this case, if you look at the left side only, imagine this as a string. We got A, G, T, A, and then some other ones. There's like millions of molecules in here. But yeah, you could represent it as a string. So say for example, you have the DNA, let's say your DNA is equal to, this is for saying some example. Let's say, okay, so this is just some letters. G is like a molecule. It's like who cares what this means? There's typically 4 molecules. Nucleotides. We have cytosine, C, guanine, and then 2 others. So there's just 4 letters. So you could represent a DNA string with 4 different letters. G, T, C, A. So in this case, I'm just making up a random one. Sometimes it's necessary to write loops to go through a DNA string. In practice, this DNA string would be like millions, maybe billions of letters. And sometimes it's necessary to count up things in it. You could calculate someone's ethnicity probably, or you could calculate like their genetic predisposition to something just by going through a DNA string and counting things up. So yeah, let's do a small example on just counting vowels. Hopefully people see like the motivation behind this. All right, so here, let's go ahead and make a file here. I'm gonna make a file. I'll call it like a vowel counter. So let me quit this. Vowel counter.java. All right, this is just gonna be a really small loop, and we're gonna evolve it into another thing later. So we'll see this again. Okay, let me go ahead and hard code a string. Like text is equal to hello world. It doesn't matter. Hello world, and then say we wanted to write a loop that counts how many vowels there are. So we should end up with like 1, 2, and 3. There's 3 vowels in here. All right. So one way you could represent it is with the for loop, because we know the range. Right? For loops are good on representing finite ranges. So in this case, it is finite because we know we should start at 0, and we should also end at the very last letter. All right, so let's go ahead and set up the loop for that. So I'll start at 0. In a lot of programming languages, we start counting from 0, meaning that the first position is 0, and then 1 is the second one. So yeah, that's why I count from 0. And then we know the upper bound. The upper bound, well, you could hard code a number here. So in this case, I mean, you could hard code 5. Hold on, let me count. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you could say it goes all the way up to 12, meaning it's going to go from 0 to 11, and then 12 will be ignored because there's 11 positions here. There's 0 all the way to 11. So you could do this. 12 is technically hard-coded, and generally we want to have solutions that will work with multiple data. So 12 is hard-coded. It would better to generalize this into the actual length, and you could grab that by using this method here called text.length. There's a lot of things you can do with strings, and one of them is you can just get the length of it. So let me just pull up some. I'm on the primary documentation. It is a little hard to read here, but the point is there is a method here called a length that returns an integer representing the length of the string. So you could test this out on your own J shell if you wanted to. Like here, if you went into J shell and you said like DNA.length, this returns an integer. So this gives us 7 here because there's 7 things in here. All right, so you could represent this as text.length. It's more general. And then increment I. This says go one at a time. All right. So here, let me do a sanity check real quick to make sure the loop is iterating correctly. Okay, let me make sure there's no infinite loops. So I'm just gonna print out every single character. Let me go print F, and then I'm gonna say the letter at position blank. The letter at position blank is some letter. I'm gonna do %C. Oh, you know what? No, here I'm gonna take it step by step. The letter at position. Okay, let me just trace through this real quick. Just so folks know here, I goes from 0 all the way to 11. So just to prove that here, let me print it out. Java vowel counter. Okay, people see what's happening. So we start counting at 0 and we go all the way to 11. All right, that's case 0 all the way to 11. There are 12 characters here, but we're off by 1 because we start counting from 0. All right, so be careful with this because you can end up with off by 1 errors. We'll talk about one later. So here we're just testing to see if the loop is infinite. It looks like it's good. Let's go ahead and verify to see if we're looking at the right text. So one way you could grab the character is by using this string method. There's a method. Let me look up string. There's a string method here. It's called it's the first one, character at. This is a method where you tell it an index, you give it a number, and then the method will return us a single character. A character is a primitive data type, by the way. It's like an integer, kind of. So we could grab it. There is a thing called a char. Or actually here, let me invoke the method first. So there's something called char at. The way you use this is like this right here. So you could say like DNA dot char at. Sorry, I'm switching back and forth. But hopefully people see the goal here. I'm just focused on this char at. You can give it like 0. This returns a character, G. All right, notice that there's one quote here. 1, 2. All right, this is pretty much what we're going to use. So the char at, text.char at. Right. Okay, so this method returns a character, so it might be useful to store it. Right. I'm going to store it in the variable called letter. All right, so char letter is equal to a single letter. And let me go ahead and print it to make sure it's good. So in the same exact print statement, I'm going to say the letter at position blank is blank. And this blank is %C. The reason I put %C is to represent a character. So pretty much this next argument letter gets substituted into here. All right, so yeah, this is an argument that substitutes into this decimal number, and then a letter substitutes into over here, %C. If you're wondering how I knew that, you could look up string formatters in Java. This is pretty much how to use the printf function. And I'm using this over here, C for character. Okay, let me go ahead and test it. So Java. Hold up, my terminal is glitched. I'm gonna switch to a Linux terminal next time because I'm more used to working in Linux, not really Windows. Let's see, Java vowel counter.java. Okay, cool. Okay, so I just ran it just to verify if the for loop is iterating correctly. Yeah, it looks like it is. Let me double check. The letter position 0 is H, and then letter position 11 is this right here. Okay, cool. Yeah, so it looks like we set it up. And I do want to mention that there's tons of rooms for logical errors and off by ones. Like this isn't off by one if I made an equal sign. Right? Can folks predict what might happen? All I did was change this condition to an equal sign. Well, what's the behavior loop gonna be now? let's see. Okay, so I just ran it and I have an error message. This is actually a runtime error, by the way. So if you kind of study what's happening, let me zoom out a bit. Okay, if you kind of study what's happening, the program does count up all the way to 11, but then we get a runtime exception later. We get something called an out of bounds exception. So this happened in the middle of a program, and it's kind of bad because it means that future statements can't run. So if I had like future statements here, right, like let's say I had more to the program here, the statements wouldn't even be reached, because if we have an exception early but we didn't catch it, well, we'll talk about what catching means, but this is an uncaught exception, meaning that the program pretty much crashed. All right, it pretty much crashed. So that's a bad thing, and that happened from this off by one error. This, all right, people see what's happening here. So I just removed it, and now we're good. Right, the reasoning is kind of like this right here. Like we have DNA. So I'm in a different environment right now. I got DNA here. I could access things at like 7 here. Can I? No, I can't access the 7th element. Why not? Because we start counting from 0. So 0, 1, 2, 3, 4, 5, 6. 6 is the very last position. So if we access 7, it's technically out of bounds. All right, we could access 6 though. See, 6 gives us A. All right, so yeah, tons of room for off by one errors. Be careful. All right. Okay, so let's move on with the point of this. The whole point is really just to see if we can count vowels. All right, let's go ahead and see if we can implement some logic to calculate how many vowels there are. So it might be useful to store like a variable to accumulate it. It's kind of like the sum, right? A number that accumulates and gets bigger and bigger. So we could initialize something like I'll call it integer, maybe number of vowels. Num vowels equals 0. Right, this is like a sum variable. Okay, and we could here. Let me comment out this print statement. That this was just for debugging. Okay, so what should we do then? All right, how do we tell if a vowel is what's it called? How do we tell if a letter is a vowel? Right, because we need to make this number bigger somehow. Right, like there's supposed to be some sort of condition where num vowels increases by 1. All right, what's the condition here? Well, the condition, well, one way we could represent it is by having like a complex condition that tests if the letter is equal to A, if the letter is equal to E, and all the other ones. So one way you could do this is by saying, hey, is the letter equal to A? Okay, and please do note that I use a single character, single apostrophe. In Java, this represents a character, meaning you can only have like one single letter inside of it. All right, so we could do this, and just to test it real quick, let me print it out. I'm gonna do this outside of the loop real quick. Actually, I'll do inside and outside. So for the inside, I'm gonna do like a print statement just to see if it's detecting it correctly. Print found vowel. We say found a vowel. Okay, this is just to see. Okay, so I just ran it. It never says found a vowel, which makes sense because we only compared for A, and then there's no A's here. But if we make the condition a little more complex, like we say or the letter is equal to E. All right, let's test it. So we should see found a vowel at least once, maybe. Yeah, cool. So we ran it. It says found a vowel. This makes sense because the condition was true in one of the iterations. There's an E right here. But there's a couple more cases we got to handle. There's 3 more other vowels. So we could say or the letter is equal to the other ones. I and then O. Or letters equal to U. A, E, I, O, U. Cool. Let me go ahead and run this. So I should see like 3 of them. Okay, cool. So I found 3 vowels. And now that we verified that it is detecting correctly, we could print it out. So I'm going to print it out outside of the loop. So I don't, this way only prints out once. I'll say there are this many vowels. There are this many vowels in the string. There are this many vowels in the string. And then I'll put a string here. So I have 2 formatters inside of this print f-func method. I got a digit here, and then I have a string. So I'm gonna put the digit as num vowels. This is a number that will substitute into here. And then now we need a string to substitute into here. So I'll put the text here. Right, text gets substituted here. So let me go ahead and test this now. Okay. So Java vowel counter, and then let's see. Let me use the VS Code one. Okay. Okay. Hopefully people can read this. So yeah, our final statement, it says there are 3 vowels in the string hello world. Yeah, so that's what this is showing here. And just to make sure our method is working, we could change this text over here to whatever you want. Like, let me make it like race car. It doesn't really matter. Race car. How many vowels are in here? 1, 2, 3. This one should also be 3. So if I run this, it says the same thing. There are also 3 vowels in the race car. Okay. The reason why I chose race car is kind of to lead up to something called palindromes. If you want to do a good, cool lab exercise, you could write some logic that detects whether or not a text is a palindrome. A palindrome is something that reads the same back and forth. So this is a palindrome because it reads the same backwards and forwards. So yeah, you could do that as a lab activity. But let me test a different one. Let's test like I'm just gonna test it. Let's see, iteration. How many vowels are in here? 1, 2, 3, 4, 5. There should be 5 of them. So let's test it. And there are 5 vowels. Perfect. All right, people cool with this so far? Okay, cool. Hope that makes sense. It would be also a good lab activity to maybe translate this to like a while loop. Like see if you can rewrite these 3 expressions into a while loop instead. Okay. This is just one way we could use to count up vowels, by the way. It's kind of flawed, but it's really only here for learning purposes. The point really was to write a loop with if statements inside of it. Right? You don't have to do it this way. There's actually more efficient ways too. Because you know this way doesn't really work with like capitals. Like if I were to put like hello world in all caps, what do you think is going to happen? It's going to give me zero vowels in a string because we didn't handle the case sensitivity here. So this solution could get better. I'll let folks think about it. How do you handle caps? There's multiple ways. In my opinion, I would probably use a different method. Like instead of comparing letters like this, there's a more powerful method here. You have to kind of play around with it though. If you take a look at the string class, there's a method that lets you compare but ignore the case. Let me see. I think it's called equals. Yeah, right here. So there's a method that compares a string to another string. This is not with characters, by the way. A character is with like a single letter. A string is like a collection of characters. So you could use this string equals ignores case, which will it's going to ignore the case sensitivity. So in my opinion, this would be better. All right. Okay, let me quit these tabs. I got too many of them open. Okay, cool. Come through on Wednesday. We're gonna make this a nested for loop later, by the way. We're gonna revisit this again. Probably 2 more times. Okay, let me see where we're at. Okay, I think that's it for today, folks. We have 3 more minutes left in class. I was planning on going through another thing called processing input, but it looks like we're not going to have enough time for that. So here, let me conclude real quick on the goal today. Today, we were really trying to go over a few common algorithms. In the beginning, we went through an algorithm that can possibly help you out with the programming project. We went through a FizzBuzz algorithm. This is pretty much testing to see if we can write a loop that goes through with if statements. We did another for loop. This is like a sneak peek, by the way. Well, we're getting a sneak peek into iterating through data structures. All right, containers and data structures, like a string. A string is a container of characters. In a couple weeks, we'll talk about arrays. So we'll see what data structures are. If you're curious what this means, there's a cool website, which I'll pull up again later. There's a website that lets you visualize data structures and algorithms. If you're planning on going into future CS classes, this is a great website if you're a visual learner. So there's things like arrays here. We're actually going to cover arrays in like a couple more weeks. But this is a data structure. It's a data structure that contains elements. It's kind of like a string. Like you know how a string contains a collection of characters. You can think of an array as a collection of something. In this case, it's like a collection of integers. And sometimes it's necessary to loop through them to do something. Like imagine this is a line. And maybe you want to cut in line. So if you want to cut in line, it's gonna involve some sort of loop. Like let's say I were to cut in line at 5 or something. I would probably have to make a loop that pushes everyone back 1. So here's what I mean. Like let me insert here. Is it insert? Okay, so let's say my number happens to be like 60. Let's say my number happens to be like 30 or something. It doesn't matter. And then let's say I wanted to cut in the 5th position of line. So let me insert. So in this case, I'm trying to cut, but one way you can represent the algorithm is by looping to the index and then kind of pushing everything over. So you see how that was kind of a loop? It looped backwards, but through each iteration it was pushing something forward. Like if I do it again, let me insert like a number on like the position 4. All right, so you see how I'm trying to insert something on 4. So it's kind of like looping through until it gets there. And then once it gets there, we can fill it in. So yeah, this is one way to visualize it. It's gonna make more sense later, but a very common loop algorithm is going through containers, which is kind of what we saw. Like we have a bunch of data and you kind of want to go through it to do something. All right, we'll do this a couple more weeks. On Wednesday, we're gonna do a lot on reading input. We're gonna spend quite a bit of time going through like different ways on looping input. You've seen some of this before, especially last week with the roulette example. If you're very familiar with the roulette example, then Wednesday will be pretty chill. But I highly recommend coming through Wednesday because it's going to give us more hints on the next programming project. The next programming project will involve looping input. So yeah, come around for that. And we'll talk about nesting too. Now, nesting is a way of putting loops inside loops. Okay, so yeah, that's about it for today, folks. We did some common algorithms. I didn't publish any supplementary material yet, but I should by the end of the week. If anything, the exercises in these first 3 sections should be somewhat sufficient. But if it's not sufficient, I do recommend lab activities during lecture as well. Okay, thank you all, folks, for being here, and I'll see you all on Wednesday, a couple more days. Bye-bye.